Imagine setting off from Earth in a spaceship, flying in a straight line through space. You keep going, never turning around, never stopping. What happens then? Could you reach the edge of the universe? Is there even such a thing? This question is one of the deepest mysteries in all of science, and there are three main possibilities. First, you might travel so far that you eventually circle back and arrive at Earth again. Second, you might fly endlessly, never looping, through an infinite cosmos. And third, the most intriguing of all, you might actually reach some kind of boundary, a place where space and time themselves simply end. If that happened, what would you see? A wall? A void? Or something even stranger? Let's dive in. Why is the night sky dark? Let's start with a question that sounds simple: why is the night sky dark? Most people would say, because the sun isn't shining on our part of Earth. But that's only part of the story. The real question is, with so many stars in the universe, shouldn't the entire sky be blazing with light? If the universe were infinite and filled evenly with stars, no matter where you looked, your eyes should land on a star. The night sky would be as bright as day. But that's not what we see. Most of the sky is dark. This is called Olber's paradox, named after the astronomer Heinrich Wilhelm Olbers. So what's going on? Is the universe infinite? To solve this, we need to go back, way back, to the beginning. About 13.8 billion years ago, the universe exploded into existence in what we call the Big Bang. Back then, the universe was dense, hot, and full of matter and energy. Ever since, it has been expanding, space itself growing larger and larger. When we look at distant galaxies, we see that the farther they are, the faster they appear to be moving away from us. Eventually, they become so far away that their speed exceeds that of light, not because they're moving through space faster than light, but because space itself is expanding. Light from these distant galaxies can never reach us. There's a limit to what we can see. This is called the Hubble sphere, a bubble around us, about 14.4 billion light-years wide. And because the universe continues to expand, this bubble grows every day. Now here's the amazing part: if a galaxy outside the Hubble sphere emitted light in the past, and the expansion of the universe slows down just enough, that light may eventually reach us billions of years later. That's how we can still see galaxies moving faster than light. Their light started traveling to us long ago. This leads us to the observable universe, a sphere around us about 93 billion light-years wide, filled with everything we can currently detect. But beyond this bubble, there's likely much more. Possibly an infinite amount. Solving the darkness. This idea also helps solve Olber's paradox. As galaxies move farther away, the light they emit is stretched, shifted toward the red end of the spectrum. Eventually, the light becomes infrared or even longer wavelengths that our eyes can't detect. So, the night sky is dark not because there's nothing out there, but because most of the light is invisible to us. What is the shape of the universe? Now comes the big question: what is the shape of the universe? It's tempting to imagine a giant sphere of stars expanding outward. But space isn't flat like paper, it's shaped by gravity and energy. Einstein's theory of general relativity tells us that space can curve. There are three possibilities. Positive curvature, like a sphere. In this case, light beams traveling straight might eventually loop back. Negative curvature, like a saddle. Here, light beams bend away from each other. Flat geometry, where space continues in straight lines forever. To test this, scientists look at the cosmic microwave background, the leftover glow from the Big Bang. By analyzing the angles of triangles in this ancient light, we can detect curvature. And guess what? The flat. But infinite. If the universe is flat, it could still be either finite or infinite. Maybe we're just seeing a tiny patch of a much larger curved structure. Just like the Earth seems flat when you're standing on it, the universe might seem flat to us because it's so big. Some estimates say if the universe is finite, it must be at least 1,000 times larger than the part we can see. But most cosmologists believe it's truly infinite. The infinite universe and the cosmic copy problem. If the universe is infinite, wild things happen. In a truly endless universe, everything should eventually repeat. There would be infinite Earths. Infinite versions of you. Somewhere out there, there could be a version of you watching this exact video, but maybe that version didn't hit the subscribe button. Statistically, these repeats are not just possible, they're expected. If matter is arranged randomly in infinite space, all patterns must occur again, eventually. It's mind-bending. Can we ever get there? Even if these infinite worlds exist, we will never reach them. Why? Because of the same expanding universe. Remember that Hubble sphere. 94% of all galaxies we can see are already beyond it. That means even if we built a spaceship that traveled nearly at light speed, we could never catch up. Every second, about 60,000 stars pass beyond our cosmic horizon, out of reach forever. Since you started watching this video, over 50 million stars have vanished from the realm of the reachable. And in the far future, say, 2 trillion years from now, all other galaxies will have faded away beyond visibility. If humans were born in that distant future, they would never know about galaxies, the Big Bang, or the true scale of the universe. They would see only their own galaxy and think that was all there was. In the end, so what lies at the edge of the universe? Probably nothing at all. No walls. No endings. Just more space, forever stretching, forever expanding. Even if the universe is infinite, we are confined to our small part of it. But in that part, we can look back in time, study distant stars, and uncover the story of how we got here.